Hello, everyone. I was just going to start our notes on chemical reactions and equations. So the first thing I wanted to talk about was what are the indications of a chemical reaction? How do you know a chemical reaction is happening versus a physical change occurring? Okay, and so you should have already done a physical and chemical change assignment. But these chemical reaction indications were in chapter 2 of your book if you need to go and check that out. But some of the indications are that there is a temperature change. So for example, that would be like one of those cold packs that you have to kind of break open. You kind of snap and then it gets colder, like it's sitting in a first aid kit, and then you snap and then it gets cold. That's a chemical change. Okay. Color. Like maybe you have two clear liquids and then you mix them together and they turn white or something like that. Another one would be some sort of bubbling or fizzing. That means a gas is released. So that means gas is being made again. And then the last one, it's called precipitate. So what a precipitate is it's when you have two liquids and that when you pour them together, it makes a solid. I'll put a video on where you guys can see that happening. But again, it's when you have two liquids and you pour them together and it makes a solid and a liquid. So there's kind of some chunky stuff then floating around. So what we're going to do now is we're going to learn how to do chemical reaction balancing, okay? So this equation right here, sodium metal reacts with water to form hydrogen gas and sodium hydroxide. That equation right there is going to be my example equation that I keep coming back to. So just make sure that you kind of know where I'm talking about there. But I am looking at this example. So I'm going to just keep coming back to that example. Okay, so a reactant, and maybe you should have already gotten this from your notes, but reactants are the things we start with. So it's the stuff you start with. So in this example, the things that we're starting with are the sodium metal and the water. So products are the exact opposite. It's the stuff you end with. It's the stuff you end up with. And from my example up there, it is hydrogen gas and sodium hydroxide. I can't spell gas. Sodium hydroxide. Because it's telling me that I started with sodium metal and water and it made hydrogen gas and sodium hydroxide, okay? So here, an arrow goes between the products and reactants. So an arrow separates the products and reactants. Another thing that we could say is that a plus sign goes between two products or two reactants. Goes between okay. The reason why the balancing chemical equations and writing chemical equations is so important is because there is this law called the law of conservation of mass. And what that says is that mass cannot be created or destroyed in a chemical reaction. We can't just poof, make something appear out of thin air. We can't just poof, make it disappear. The atoms are being rearranged. So in order for chemical reactions to occur, things are rearranged in certain ratios, okay? So the product side of a chemical reaction must have the same exact number and type of elements as the reactant side, and that's why this is super important. So there's a few different steps while we're balancing equations. Step number one is you have to read and understand the equation. And again, our equation is that this sodium metal reacts with water to form hydrogen gas and sodium hydroxide, okay? You're going to write the chemical equation using formulas and symbols. You're going to check the equation for atom balance, and then you're going to use coefficients to balance the equation. So we never change the subscripts in the formula. So when we're balancing, the subscripts are off limits, okay? You never change the subscripts. You use coefficients. So coefficients is this number out front, okay, like in front of water. That is saying you need 2 water molecules. You cannot change that little molecule there, that little subscript in the water molecule. That is off limits. For balancing, you just put numbers out front, okay? So what's going to happen here? What goes on the right side? We're going to just go through these steps, and you will not have to use these steps all the time. We're just going to kind of work our way through with our example. But it says, what goes on the right side of the arrow? What goes on the left? So here, let me give you our arrow. So on this side, we have the reactants. And on this side, we have the products. And we already know what our reactants and our products are. So we can write the equation out right here. So this equation, it says sodium metal. Sodium metal is just Na, it's from my periodic table, plus, because I have 2 different reactants, my other one is water, and my plus sign goes between 2 products, or 2 reactants. So there's my reactants. Sodium metal plus water reacts to form hydrogen gas. Remember, hydrogen is a diatomic, so it has to be H2. You have to remember your diatomics. You cannot just let it be H. Those diatomics are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. You should have those written down somewhere. So formula for hydrogen is H2, and sodium hydroxide. So sodium hydroxide, we're going to have to remember how to do our formula writing from last unit. Sodium is Na, hydroxide is a polyatomic, it's OH. So now let's check our charges. Sodium's a +1, hydroxide is a -1. We already balance out, we're good, so I can erase those. Okay, so now we are going to check for atom balance. And what that means, I will show you my process. If you have a process that you like different, go ahead. But what I like to do is I like to, underneath my arrow, I put the different types of elements that I have. So I have sodium, I have hydrogens, and I have oxygens, because that's the different types of elements that I have each side of my arrow. So let me move this down so it makes more sense. So I'm going to check for atom balance. So on my reactant side over here, I only have 1 sodium. So I'm going to put a 1 on the left-hand side. On this side, I only have 1 sodium. So I'm going to put a 1 over there as well. Now I have 2 H's on the reactant side. I have to be careful here because on the product side, I have 1, 2, 3 H's. And then I have 1 O on the product side, or 1 reactant side, and 1 O on the product side. So the H's are what's throwing me off, okay? So it says we're going to have to choose coefficients to balance. So what I'm going to do, and I'm just going to do it up here on my original one that I was working on. I'll just choose a different color, and I'm not going to rewrite it. But what I'm going to do here is I just have to kind of start figuring out what's going on here. So what number could I put in front of something to make it change? So this hydrogen is what's messing us up. This side of the equation, no matter what number I put in front of hydrogen right here, or in front of the water, I'm always going to get an even number of hydrogens because it's timesing by 2. This one, I'm always going to get an even number of hydrogens. This is the one that's kind of messing me up over here. So I'm just going to try and make it an even number. So I'm going to put a 2 in front of this as a coefficient. So now I've changed my atom count. Now I have 2 sodiums. I have 4 hydrogens because I have 1, 2, 3, 4. This kind of goes to each one. And I have 2 oxygens. So now I have to go to my reactant side and fix stuff. I have to put a 2 in front of sodium. Now I have 2. And I have to put a 2 in front of my water. Now I have 4 and 2. So now I'm balanced. That is the correct balanced formula. Okay? I'll put up a video to kind of help you out as well. And then there's also a game that you guys will be able to play. So let's do a couple more. This is an activity. I'll post this sheet on the Google Classroom as well as the key so you guys can try it out for yourself if you would like to. But it says atoms are not, we're going to write created or destroyed during a chemical reaction. Scientists know that there must be equal number of atoms on each side of the reaction, or you could write the word equation. To balance the chemical equation, you must add coefficients in front of the chemical formulas in the equation. You cannot add or change or subtract. You can't do anything with the subscripts. Okay, so again, my steps are over here on how I'm going to balance. This worksheet has worked it out a little bit. They don't put the atom count underneath the arrows like I have. They just do it on either side. If you don't even need to do the atom count, that is fine. But I just wanted you to show you how you would kind of work this out. So on my reactant side for magnesium on this, I have 1 magnesium. On the other side, I have 1 magnesium. On the reactant side right here, I have 2 oxygens. And I have 1 oxygen. So the oxygen is what's throwing me off. I need to change it. I'm going to put a 2 up here so that now I have 2 oxygens. I also have 2 magnesiums though. So now I need to put a 2 over here so that my magnesium cancels out. So that is the correct formula there. Let's do a few more. I have 1 calcium and 2 oxygens on my reactant side, and I have 1 calcium and 1 oxygen on my product side. I'm going to change this to a 2 to get my oxygen to be the same. That also changed my calcium though, and I'm going to also have to change my calcium on this side to make it balance. You're just trying to get your numbers to be the same. On the next one, I have 2 N's, I have 2 H's, I have 1 N, and I have 3 H's. So a good hint, you guys, is save the oxygens and hydrogens to last because they kind of get to be pains in the butt. For sure, save the oxygens. Normally what happens, and typically, not always, but lots of times if you work on something else, another element, it fixes the hydrogens and oxygens for you. So on the reactant side, I have 2 nitrogens. I'm going to have 2 nitrogens over here. But hey, look what happened. That has now changed my hydrogens to be 6. So what number do I have to put in front of hydrogen over here on my reactant side to have 6? And that is a 3. Because 2 times 3 is 6. Now I'm good. Okay, let's try and do a couple more before my time runs out here. Oops. Copper, I have 2, 1 and 1. I have 1, 1, and 2. And again, I'm just looking at the subscripts for my counting there. Okay. So I have 2 coppers. I have 2 coppers now. I have 1 oxygen and 2 oxygens. Oops, I messed this up. So I'm gonna have to put a 2 in front of this one over here. Hey, look, that now changes my copper to be a 4. This is why you should do this kind of stuff in pencil, because I didn't do anything wrong, but now I have to go and erase that original 2 that I had there and put a 4. Now we're sitting pretty. And then the last one, 2 and 2 and 2 and 3, because there is 3 oxygen on this side. 1, 2, 3, okay? Again, this is a whole even odd situation. The oxygen and the water is what's throwing us off. I'm going to put a 2 out front of that. I now have 4 oxygen on this side. I have 2 right here, plus another 2 right there. I have 4 hydrogen. I'm going to put a 2 in front of this. That gives me 4 of everything. All right. This is the side I'm going to let you guys try on your own. I'm going to be posting this in the Google Classroom underneath the materials. So just take a moment and check that out. I will now go on to talking about the notes of the types. So go and watch the videos for the types of reactions.